Most telecom students may think their choices stop at cellular, LTE, 5G base stations. But telecom is much bigger than that. Today, I want to introduce satellite communications, not from a theory point of view, but from a career point of view, especially for final year students and fresh graduates. This is not about saying SatCom is better than cellular. It's about understanding your options. Cellular dominates university courses, internships, and job ads, so it feels like the only path. But many telecom fundamentals apply across domains. SatCom is one of those domains where demand exists, but awareness is low, especially among students. If you understand the fundamentals, you are not limited to one industry. At its core, SatCom is still telecom. We still deal with RF modulation, noise, link budgets, interference. The key difference is distance and the environment. Instead of meters or kilometers, we deal with hundreds or thousands of kilometers. So, the physics matters more, and the small mistakes matter a lot. In cellular, it's about dense networks and mobility. SatCom is about coverage, reliability, and reach. In cellular, you work with dense cells, fast iteration, handsovers, and constant optimization to squeeze more capacity from crowded spectrum. Things move fast, and the improvements often happen in small, incremental steps. Satellite communications feels very different day to day. Instead of dense networks, you think about long links that span hundreds or thousands of kilometers. Instead of rapid iteration, you focus on reliability, coverage, and system-level trade-offs that must work the first time and keep working for years. From a career perspective, neither field is better. They simply reward different personalities and interests. If you enjoy fast-paced optimization and open-scale networks, cellular might feel nature. If you love big-picture engineering, long-term thinking, and solving problems at global scale, SatCom can be incredibly rewarding. Both fields are part of the same connected future, just from very different perspectives. You often hear GEO, MEO, and LEO mentioned. For careers, this affects latency expectations, system complexity, how often networks change. LEO systems feel closer to cellular in terms of scale and automation, while GEO systems feel more traditional and conservative. Let's pause here for a moment. If you are coming from a cellular background or just starting your career in telecom journey, everything so far might feel familiar, but also a bit different. In the next section, we'll move from how SatCom works to what roles actually exist, and where new graduates and early career engineers typically fit. This is where SatCom starts to become a real career option, not just a technology. SatCom careers are not just satellite designers. Many roles look familiar if you have studied cellular, such as RF and antenna engineers, payload and transponder engineers, ground segment and gateway engineers, network operations and monitoring, test, measurement, and certification. If you understand RF systems or testing, you are already closer than you think. Just like in cellular, the word satellite doesn't define your daily work. The company type does. Across the SatCom industry, you will find several major players: satellite operators, satellite manufacturers, ground equipment vendors, and integrators or test labs. And each of these roles feels very different day to day. Operators are focused on uptime and service delivery. Their work is about keeping networks running, managing capacity, and making sure customers stay connected. Then you have labs and the integrators, where the focus is validation, compliance, and proving that everything works together before deployment. The same job title can mean very different work depending on where you sit. Something we already saw in the cellular career discussion. So, when exploring SatCom, always look at the company type first. This is probably the most important reassurance for students. Your cellular knowledge is not wasted if you move into SatCom. In fact, many of the core skills transfer almost directly. RF fundamentals remain the same. Propagation, antennas, noise, and link margins still rule everything. The physics doesn't change just because the base station now is in orbit. Link budget analysis becomes even more important. Instead of few kilometers, you are now thinking about hundreds or thousands of kilometers. But the methodology is familiar. Interference troubleshooting also carries over. You still ask the same questions. Where is the noise coming from? What changed? And how do we isolate the problem? And finally, measurement discipline. The careful, methodical approach you learn in cellular testing is incredibly valuable. Where mistakes are costly and fixes are slow. So, if you are moving from cellular to SatCom, you are not starting over. You are building on a very strong foundation. At the same time, SatCom really stretches you. You deal with longer delays, much larger link margins, and systems that evolve far more slowly. Design changes are not pushed weekly or monthly. Sometimes they take years. You spend less time worrying about handovers and much more time thinking at the system level. Physics, orbit constraints, power, and latency. In SatCom, the limits are real, and you design around them. SatCom can be a great fit if you enjoy deep technical fundamentals and thinking in terms of complete systems, not just individual components. The work often revolves around RF, link budgets, propagation, and making design decisions that must hold up for many years. Compared to cellular, the pace can feel slower. You don't iterate every few weeks or months. Instead, you spend more time analyzing, modeling, and getting the design right before anything launches or deploys. But while it may be slower, it's often much deeper. You are solving problems that operate at global scale, where reliability and long-term performance matter more than rapid change. So the real question isn't prestige or which field sounds more exciting. The key is alignment, choosing the environment that matches how you enjoy working and thinking as an engineer. You don't need to decide your entire career today. Start small. Try a university project related to satellite or RF systems. Apply for an internship. Spend some time around the ground terminals, test equipment, or an RF lab. You don't need years of experience to figure it out. Very often, one hands-on experience is enough to tell you whether this field excites you or whether it's not for you, and that clarity is already a big step forward. Telecom careers are bigger than job titles and technologies. If you build strong fundamentals, you gain mobility across cellular, SatCom, and beyond. Choose a path based on how you like to work, not just what sounds impressive. And if you want more videos comparing telecom career path, let me know. Thank you.